Welcome students. Let us see this question. This question says the diagram shows an object of mass 2.4 kg on a smooth horizontal surface. So this is a block having the mass 2.4 kg and it's a smooth surface. It's lying on a smooth surface, so its coefficient of friction is 0. A force F, capital F, as you can see in the diagram, acts on the object at an angle of theta, at an angle of acute angle theta to the horizontal as shown in the diagram, and where tan theta is 4 by 3. A force of 36 Newton acts on the object towards the right. So there is a force which is acting on the right side, towards the right, on this block. The object is in equilibrium. What is the magnitude of the normal contact force exerted on the object by the surface? So first of all, this is our surface and the question is saying what is the normal force? What is the normal contact force exerted on the object by the surface? So it means we have to find the normal force, right? Normal means this is the perpendicular to the surface and this is applied by this surface, and we have given the gravitational field strength. What is the meaning of this gravitational field strength? The gravitational field strength is basically G. How we can know this? See, you know F is equals to mg. So what is the G here? So G is equals to F upon m. What should be the unit here? Force, that is the Newton, m, that's the kg. So Newton per kg, right? Newton per kg is the unit of small g, that is the acceleration due to gravity. Generally we say acceleration due to gravity. Here it's a name given as gravitational field strength. That's also true. So this is the question. We have the option. So for this type of question, what we can do first to sketch the free body diagram. So I'm going to draw its free body diagram. So please try to understand. So this is the mass. This is a block having mass m. This is kept on a surface and its coefficient of friction is 0. So and there is a force of 36 Newton acting towards right. There is a force acting in this direction at the angle of theta with horizontal. First of all, there is a very important concept: which force should be break in its component. The concept is, if we want to sketch free body diagram, so the concept is which force should be broken first, right? So the concept is, if any force, if any force that is not in the direction of motion, if any force that is not in the direction of motion or perpendicular to the direction of motion, right? If any force that is not in the direction of motion or perpendicular to the direction of motion, that force needs to be braked. That force need to be braked. I'm trying to say, if any force that is not in the force of direct, that is not in the force of movement, direction of movement basically, and not in the perpendicular direction of movement, right? If any force that is not in the direction of movement or not perpendicular to the direction of movement needs to be break in its component. This is the major concept. This is the very important concept you should know. So let's try to think which force is not in the direction of motion or perpendicular to the direction of motion. As you can see, uh, see, if we push this block, so the major possibility either it go in this direction or it should go in this direction, right? It cannot go up and down because in this bottom side this has the horizontal surface, so we are assuming that it may be uh, it may try to move in along x direction. So this force is okay. This force need not to be braked, and this force F, which is acting at the angle of theta, needs to be braked. So let us try to break this force. So how we can break its components? See, this is the force F. its component will be broken like this. In this two direction it will be break. If this is the angle theta, see both are x-axis, both lines are parallel and alternate in interior angle. With the help of alternate interior angle, this angle will be theta. So this component will be f of cos theta and this component will be f of sin theta. I hope you understood this, how I have done this quickly. The if if I want to explain this quickly, the concept is, if see the theta angle is given with any axis, right, then the cos component will be along that axis, right. If here theta is along theta is the angle with the x-axis, so along that axis its cos component will be there. So this is the f cos theta, right. Next it's mg, that is the vertically downward, and there will be a normal force that is acting vertically upward, right. Now since the object is in equilibrium, according to question, body is in equilibrium. So what is the meaning of equilibrium? The basic meaning is net force will be equals to 0 and net torque should be also 0. Here we don't use net torque, but the basic condition is net force and not net torque, both should be 0. That's the meaning of equilibrium, right. Here we have to apply net force is equals to 0. It means net force along x direction should also be 0 and net force along y direction should also be 0. What is the net force along x direction? See, this is acting towards right, this is acting towards left, so it means f cos theta should be equals to 36 Newton. Since we know tan theta is equals to 4 by 3, from here you can get sin theta as well and cos theta as well very quickly if you draw a right angle triangle, and this is the theta. So tan theta is 4 by 3, its perpendicular is 4, this is 3, so this should be 5. So write sin theta directly, that's a perpendicular upon hypotenuse, so it should be 4 upon 5. Cos theta will be 3 upon 5, that is the base upon hypotenuse. So I don't know, f cos theta is 3 by 5 should be equals to 36. From here we can get f is equals to 60. So f is basically 60 Newton, right. Let us do the net force in y direction. So this mg is vertically downward, this f sin theta is also vertically downward, so mg plus f sin theta should be equals to my n, that is the vertically upward, and we have to find this n. So basically we have to find this. What is the mg? Mass is 2.4 kg. See, it is written 2.4 kg, so it should be 2.4 into 10 because g is 10. I have explained earlier in the beginning of the question. F is 60, sin theta is basically 4 by 5, so just try to simplify this. 12, so this is 24 plus 48, so it's 72. So it means the normal force will be should be 72 Newton. Let us try to find its option. Yes, it's option number E, and that's the correct answer. So students, I hope you have understood the fundamental of Newton's law and Newton's law of motion. So if you like this question and explanation, please like this video and share it among your friends and other students. Thank you. Thanks for watching.